What's going on, everybody? I'm Rob from Boosted Cycle Performance and Fabrication, and this is the first official video for the HP Tech series. My premise for this whole series is to kind of get more in depth and show all you guys out there, you at home, guys that are doing the wrenching by yourselves or want to learn how to do it by yourselves, kind of take away the mystery of what it takes to build these bikes. It's not really voodoo magic. A lot of people just, even if they're competent mechanics, they'll, once it comes to getting into a motorcycle engine, they're like, no, I don't want to mess with that. So with further videos in this series, if everything goes really good, I want to, keep going and showing you guys, what it takes to, whether it's changing the transmissions or measuring for bearings, how to build a complete engine, get in depth on tuning. For a lot of you guys that have shops that have built you a bike and take it out and race it, you guys some people don't know how to check the tunes and make sure everything's safe and running good. So that'll all come later on. As long as these videos do good and it's people are getting stuff out of it, I'll keep making them. My premise for HP Tech series also is to test the limits. So for years, especially with the Gen 2s, once you go turbo with them, it's said that you can only make 300 horsepower before you drop the valve, before you start floating the valves, or you push the head gasket because they got really high compression. 350 horsepower. The rods are supposed to exit the block. 400 horsepower, the pistons are supposedly supposed to break. And while I've been developing my own turbo kits that I'll maybe eventually be selling, we'll see. I've been pushing those limits, and you guys can look back through my YouTube videos and see that I've pushed far past those. So at one point, I turned the boost up on BP X98 fuel and made 330 horsepower on 7 PSI on a completely bone stock Gen 2 boost, the orange 08, which I call it Lucy. And I rode around like that for over 1,000 miles, just beat the shit out of it, and never had any problems with it. And then later on, I came back and then I turned the boost up to 15 pounds and made the 434 horsepower. And I should have showed that clip before this, where it looked like it pushed the head gasket, which, come to find out, that wasn't the case. Actually, what ended up happening was once I took the engine apart, the head gasket was fine. What was wrong, and I noticed this when I was taking the bike apart, I pulled the radiator cap off. The radiator cap felt really loose on it. Well, I ended up going and testing it, and the radiator cap was actually bad. So it wasn't keeping pressure in the cooling system, and it actually ended up overheating on the dyno. But if you take it out and ran it on the street, you get enough air going through it, it'd stay cool and it wouldn't push any coolant. So probably could have pushed it harder. I don't know how much, but I was fully prepared to scatter the thing because I got a shelf full of stock pistons, rods, all sorts of crap right over there. If I broke something, and I got a scrap pile full of pistons and rods over there, so I wasn't really worried about that. So that brings us to where we're at here today with these parts behind me. So I pulled Lucy's engine apart, and the head gasket was good. The head studs didn't seem to have stretched or anything like that. The pistons weren't burnt. The only thing that I did find on the pistons were the top ring, because the factory ring gap is so small on them. It did end up getting real hot, and the ends of the rings ended up butting together, and it didn't break the piston, but it got them to the point where they butted together. And now if you look back here, I don't know if you can see it. You see, so this is the second ring right here. Sorry guys. So if you see this, the second ring is nice and sprung open, but you look at the top ring here, and the top ring isn't the same. So the ring got so hot that it swelled and pinched together, and now you see you can barely even move it. Whereas the second ring here, you know, this is how it should be. The top ring, it got too hot and expanded too much because the ring gaps were too tight. So that was the worst. That was the worst damage that caused. It didn't do anything to the cylinders. You know, the head is fine. You know, you can see by the tops of the pistons, the tune was spot on. I mean, I say all of them. I got 3. I don't know where the other one went, but you can see the tune was, you know, spot on. We're running Pt.1 fuel, and I think factory ignition timing, or no, I had about 2 or 3 degrees pulled. So I got to thinking while I was taking this engine apart of how I could do more power and keep it together. And I came up with this idea because there's like 2 extremes right now if you want to make more power. So say you're the guy that has a stage 1 turbo kit that has a turbo already that's capable of, you know, 400 horsepower, but you know, you got a completely stock engine. So there's really 2 ways you can go with it. One is to do a base spacer motor, and I think, and I'll flash the exact price up on the screen here, but I want to say it's about $1,000 for the base spacer, the head studs, valve springs, head gasket. I don't know if I said spacer already. And then you can bump the boost up, and you make about 350 horsepower. That's the known safe spot, 350. I've done 350, 360 on base spacer motors for many years, and I know I have several customers that are right around that area too. It's a good safe number there. Could it go more? Yeah, probably. But the next step is doing a full built motor. So between, you know, pistons, rods, bearings, lower stud kit, you know, having the cylinder sized, the valve job done, and all that stuff. I mean, you're on the upwards. I mean, you're over $3,000, and that's if you're doing the work yourself. You know, buying the parts off the internet. So I kind of wanted to look to like a middle ground, because there's a lot of customers rather, when they do a built engine that can handle anything you throw at it, they find that usually the 400 horsepower capable turbo is usually more than enough to get them to their goals, or it's more than enough to scare them. So a question I see get asked all the time, I'm a sponsor of Hayabusa, DazukiHayabusa.org. I see questions get posted on there, and like Psycho Bike and like a whole bunch of other you know, high performance bike outlets about these cheap rods. There's rods that are available on eBay. I think it's like $400 for a set, and you know, that's a, you know, $600 savings over going with like a Wassner rod or you know, any other rods. A couple of other rods out there, and you know, people are quick to jump on the internet and say, no, don't use it, you get what you pay for. They'll break, but nobody's ever tried them. Well, a couple months back, I had a manufacturer, it's a Chinese manufacturer, contact me and asked me if I wanted to try a set of their rods, which would be comparable to the rods that are for sale on eBay. Now, the rods that I've found on eBay, if you look at them, there's one thing I didn't like about any of the rods I've seen on there, and it's where the oiling holes are positioned on the wrist pin. On any of the rods on eBay, it's positioned right on the top, so there's no way for the oil squirters to hit them. Whereas the rods that I sourced actually have squirter holes right on each side of them. So see right there, there's a hole there, and there's a hole there. And so the oil squirters can squirt oil up onto the wrist pin. Like on the other rods that I've seen, they're just directly on the top. And so you can't get oil there. So that's why I really never messed with them, because I kind of knew right away that you run into oiling issues with those. So I didn't mess with them. So I had that company step up and contact me and want me to try some of the rods. And I got to thinking, maybe I can find a middle ground and make more horsepower for less money, and see if it's a viable option. Is something I can pass on to my customers. So that brings us to what this episode is all about. So the premise is making a 500 horsepower capable engine for $1,500 or less. And I say that because this is geared towards a guy that's got like a stock motor Gen 2 Hayabusa with a Stage 1 kit on it. He's already got the turbo kit, which is probably capable of 400 horsepower, and wants more, but can't afford a full built motor, but is dancing on what the known limit is of just a base spacer motor. So that's where we're at with these. So I'll show you here in a second what parts I have and what I'm trying to do with everything. So let's go over here and we'll check it out. So here's all the parts we got. It's pretty much all the same stuff you would use if you're just doing a base spacer motor, with a couple of exceptions. So of course, a good head gasket, 65-pound valve springs, the HD stud kit with nuts and the washer. There's a 0.08 base spacer and the adjustable can gears. And with the exception of the main studs, this is pretty much everything you would do with a base spacer motor. So here's where this setup differs with the from a base spacer motor. So I am adding the main studs, and I'm using these off-brand forged rods, but using stock pistons. Now, in the past, I've actually used stock pistons and gotten over 500 horsepower with them before. The only thing I did when I did that was I opened up the stock rings. So just got the rings real big, because the problem with the stock rings are they're really thin, so they heat up a lot faster. So for this engine, I already got these rings, but so we're using the stock rings, and the top rings are gapped at 22, and I have the bottom rings gapped at 24, and that should give us plenty of space for the plenty of space for the rings to expand, and not have to worry about them butting together. Let's get to the meat and potatoes of this build, and it's these rods. So these are a no-name rod, manufactured overseas, and their price point's right on par with what you can get from eBay. I've measured the big ends and the small ends, and after torquing the rod bolts, and all of the big ends of the rods are exactly the same. So they fall on par with, if you've ever built an engine before, you know Suzuki classifies engines by a Type 1 or a Type 2 rod bearing, and all these measured out exactly within spec of a Type 2 bearing. So there's that. Now, the one thing I did opt for, these are actual ARP2000 rod bolts. They gave me the option of some other types of rod bolts that were a lot cheaper. These rod bolts for the set were like $75, I think. But I mean, I'm all for saving money in this build, but yeah, a good set of rod bolts will go a long way. So another thing that I'm going to do differently from a base spacer engine is, so usually you run a base spacer to lower the compression, and with the base spacer engine on the Gen 2, don't quote me on it, I can't remember off the top of my head, but I want to say it drops it from 12.5 to like 10.5, I want to say. Don't grill me for not knowing off the top of my head. I'm not going to run a base spacer. And if you're not running a base spacer, you don't have to worry about putting the adjustable cam gears on. If you are running a base spacer, because it raises the deck height up, it throws off the timing marks on your cams, so you have to re-degree them once you put a base spacer in. In this case, I decided to not run a base spacer, and now I'm actually going to run stock compression. Current turbo that I have on my bike right now, on a lower compression motor, I don't think it'll hit 500 horsepower. Another thing too is running that high of compression, even on X98, is generally, it's really pushing the limits, so you really got to keep on the tune. But like I said, I really want to test the rods. But where my train of thought is going with this, if I can make 500 horsepower with these rods and stock pistons, really leaning on it, for the guy that already has the Stage 1 kit and is looking to upgrade the engine to handle more, I feel like stock pistons with these rods will be more than enough to handle, 400 horsepower, and it'll save you a whole bunch of money. Now, the other thing that we're doing is I am running stock valves. See, these are the stock valves, and I already went ahead and put the 65-pound valve springs in this head. So this head's already set up, ready to go. Because we're trying to save money, the engine did have really good oil pressure. So I'm gonna go ahead and take a sloppy mechanics approach to this. And I wouldn't do this on a customer's bike, but being as this is my own bike, I'm just gonna go ahead and reuse the stock main bearings, because the stock main bearings actually look pretty good. So that's where we're at with this. So let's go ahead and start putting this thing together. So what you guys just saw me doing here is, so I already measured the crank and the inside diameter of the rods here. to get my bearing codes, and then you order bearings, and then what I do, this is the most exact way to do it, but you install the bearings, you torque it to spec here, and then you take the measurement with your bore gauge here. Bore gauge isn't the right term for these. I forgot what it's actually called. And then you measure it with your micrometer, and you get your reading there. And then you measure the same journal that rod is going on, and get the other number, and you take those two numbers and you subtract them, and that's your oil clearance. So all these are a little bit on the loose end, but they are definitely still all in spec. So next thing we can do here is hang all the rods on the crankshaft here, and then we can keep moving forward. Unfortunately, it looks like the GoPro died partway through, but as you can see, the cases are together. The crank is in and torqued. The rods are in and torqued as well. Of course, the transmission's in, and should be able to spin it over by hand. Yep, spins over nice by hand. So. So far so good. Like I said, I reused the main bearings because why not? They didn't look bad, and why not? It's my bike. All right, guys, I'm gonna go ahead and end it off here, seeing as the bottom end's pretty much together, minus the pistons. So go make the top end and the cylinders and all that crap. Make that another episode. If you guys like the idea of this, if you guys like the concept, please like and share. And please subscribe to the channel. On top of all the normal dyno videos that I post, and I have, probably close to 50 posted of all sorts of different combinations. I'll be posting these HP Tech builds, and the next one I'm going to do is it's a 2020 Busa. It's completely stock, and doing 1,000 horsepower plus. It'll be 1,000 horsepower just on boost. I don't know if the dyno, if we're going to be able to read that on the dyno, just because of traction, but it'll definitely be capable of making that. And then we'll also have nitrous on it. Again, I don't know if we're going to be able to see that on the dyno, but I'm damn sure going to try. But it'll have a max ECU on it. We'll have a big stroker crank in it, all the biggest, the best, the baddest, a Gen 2 Garrett GTX 3586 or 89 or whatever it is. So it's got a lot of really badass stuff, and they'll be building a full standalone harness for it, and a crank driven fuel pump, mechanical fuel pump. So it'll have all sorts of cool stuff. Carbon fiber wheels, carbon fiber bodywork, everything. And we'll also be doing a supercharged B King build, another one. It'll be the second one in the country that I've built. So like I said, if you like this whole premise, this whole idea, I'll keep doing it. Like I said, just please share it with all your bike buddies, and let's see where this goes. Take it easy, guys. Hey guys, thanks again for watching. Be sure to like and subscribe, and be on the lookout for part 2 of this HP Tech series. Thanks again for watching.